Hello everyone. Today we are discuss about adaptive equalization and linear equalization. Equalization. Equalization compensates for inter-symbol interference created by multipath within time dispersive channels. Inter-symbol interference caused by multipath in band limited frequency selective time dispersive channels distorts the transmitted signal, causes bit error at the receiver. Inter-symbol interference, recognized as the major obstacle to high-speed data transmission over mobile radio channel. The term equalization can be used to describe any signal processing operation that minimizes inter-symbol interference. Equalizer must be adaptive since the channel is generally unknown and time varying. Adaptive equalizer. An adaptive equalizer is an equalizer that automatically adapts to time varying properties of the communication channel. It is used with coherent modulation such as phase shift keying, mitigating the effect of multipath propagation and Doppler spreading. Operations modes of an adaptive equalizer: training and tracking. First, a known fixed length training sequence is sent by the transmitter so that the receiver equalizer may average to a proper setting. The training sequence is typically a pseudo-random binary signal or a fixed prescribed bit pattern. Immediately following this training sequence, the user data, which may or may not include coding bits, is sent. The adaptive equalizer at the receiver utilizes a recursive algorithm to evaluate the channel and estimate filter coefficients to compensate for the channel. The training sequence is designed to permit an equalizer at the receiver to acquire the proper filter coefficients in the worst possible channel conditions. The adaptive equalizer is continually changing its filter characteristics over time. The time span over which an equalizer converges is a function of the equalizer algorithm. An equalizer is usually implemented at baseband or at IF in a receiver. Since the baseband complex envelope expression can be used to represent bandpass waveforms, the channel response, demodulated signal, and adaptive equalizer algorithms are simulated and implemented at baseband. Communication system with an adaptive equalizer. A block diagram of a simplified communication system using an adaptive equalizer at the receiver is shown in the figure. If x of t is the original information signal and f of t is the combined complex baseband impulse response of the transmitter channel, and the RF or IF sections of the receiver signal received by the equalizer is expressed as y of t equal to x of t integral f of star f of t plus n b of t. This is the communication system with the adaptive equalizer in the receiver. Where f of t is the complex conjugate of f of t. n b of t is the baseband noise at the input of the equalizer. and denotes the convolution operation. If the impulse response of the equalizer is Heq of t, then the output of the equalizer is x of t into g of t plus nb of t into Heq of t of the convolution, where g of t is the combined impulse response of the transmitter channel RF and of IF section of the receiver and the equalizer. The complex baseband impulse response of a transversal filter equalizer is given by Heq of t summation of n of c of n dou t of t minus n of t, where Cn are the complex filter coefficients of the equalizer. The desired output of the equalizer is x of t, the original source data. Assume that nb of t is equal to 0. Then, in order to force d of t equal to x of t in equation, g of t must be equal to g of t equal to f of t into Heq of t equal to del of